Video 6.8, Hydrates. Alright, this is for honors class only, so if you're CP class, unless you really want to learn about hydrates, you don't have to watch this. So this is for honors. And here we go. Alright, first of all, what is a hydrate? Well, when people say, don't forget to hydrate, especially athletes, what are they talking about? They're talking about this, water, H2O. So for us, don't forget to hydrate means don't forget to drink water. When it comes to chemistry, it deals with water as well. And hydrates, okay, when we talk about hydrates, are chemical compounds that actually have water molecules bound to their atoms. Okay, so you actually have your structure here, and I have misplaced my pen, hiding right there. Here we go again. So, for hydrates, if we're talking about a compound, the water molecules are bond to the atom in the compound, meaning you have a compound here, and the water molecules are kind of like in between the structure of the compound. So, if you had like copper and chlorides, and copper's positives and chlorides are negative, all right, and you have these copper chlorides that are together, you have like water molecules that are inside between these structures. Okay, this is known as a hydrate. Okay, so that's what we're going to be talking about today. Now there are different types of hydrates, and I'm going to show you some, and we'll look at these. This right here, if you look on, if you can see this carefully, this says copper 2, and it has a little dot here, and it says 5H2O. This is known as copper 2 pentahydrate. Okay, so this copper 2 sulfate pentahydrate. All right, there's water stuck in, all right, side of this compound. Okay, this looks kind of like a salt. It's gritty. There's water in there. Here's another one, copper 2 chloride. On the formula, it has a little dot, 2H2O. Okay, this is called copper 2 dihydrate. There are 2 water molecules for every copper 2 chloride stuck in here. Alright, we got another one, sodium thiosulfate pentahydrate, dot 5H2O. We have a trihydrate here, dot 3H2O. And then sometimes, alright, what you can do if you don't want the water in with your compound, there are different ways to do this. There are actually chemicals that can absorb the water better, and will take the water out, but you can also, there's some ways to heat it up as well. And if you have something like sodium sulfite that can have water in it but doesn't, they call it anhydrous. Okay, and I'll spell that out, or you'll see that in a few minutes. So anhydrous, if it doesn't have any water stuck in it. So the prefixes that you need to know are on this sheet here. They shouldn't be much different, because you should have seen these before when we were naming compounds. So mono means there's one water molecule inside of every part of this compound you have. So you have ammonium oxalate here is the name of this. So for every one ammonium oxalate, you have one H2O. Di is the prefix for 2 water molecules, so this is calcium chloride, dihydrate. For every calcium chloride, you get 2 waters. Trihydrate, this is sodium acetate here. And so for every 1 sodium acetate, you get 3 waters, and you can kind of get the gist of this. So tetra, penta, hexa, hepta, octa. Notice we skip nona and just go to deca. Alright, we're going to need that periodic table. We'll come back and forth. And so what you're going to need to know for now is, well, how do we know how many water molecules are inside of a compound? Okay? So a hydrate is found to have the following percent composition. Okay, you should remember how to do that. So 48% magnesium sulfate, 51.2% water. What is the formula and the name of this hydrate? Alright, first step. Take your percent, put them into grams. That should sound familiar. So we have 48.8 grams of magnesium sulfates. Okay, so grams of this entire part of the compound. And we have 51.2 grams of H2O. That's your first step. Now your next step, maybe you guessed it, convert to moles. So grams is going to go down here. We want moles of our magnesium sulfate. We're going to do the same thing with water. Alright, gram and mole together. You should know my mole number is 1. Grams we get from the periodic table. So we scroll back here and find magnesium is 24.3. So I'm going to do it right here, I guess. Magnesium, 24.3 grams. There's only 1, so we keep that. Alright, sulfur, 32.1 grams. There's only 1 sulfur, that's good. And then oxygen is 16.0 grams. And there's 4 oxygen, so I need to multiply this by 4. When you do that, you get 64.0 grams. And then we're going to add these 3 numbers up. Okay, I'm going to grab my calculator to be able to do this. So don't mess up. So 24.3 plus 32.1 plus my 64. And when I added these up, I got 120.4. We added those. So 120.4 grams of magnesium sulfate goes down here. We're going to do the same thing for water. Hydrogen on your periodic table is 1.0 grams. And oxygen, we just found it, is 16.0 grams. For H2O, we have 2 hydrogens, so that needs to multiply by 2. We'll use H2O a lot in here, so eventually you'll probably remember this molar mass. But the molar mass is 18.0 grams. So 18.0 goes here, and a 1 goes right there. Let's plug it into our calculator. 48.8 divided by 120.4. And this is going to give me 0.405 with 3 sig figs moles of magnesium sulfate. Plug this in my calculator. 51.2 divided by 18. And I get 2.84 moles of H2O. Okay? So to recap, step 1, all we did is put our percent into grams. Step 2, convert grams to moles. Alright, next step. Okay? You're going to take your moles of H2O, it's always going to be your moles of H2O, divided by your moles of your compound. For us, our H2O was 2.84 moles. And our compound was 0.5405 moles. Alright, when you do this, just about every time, if not every time, you are going to, well, every time, you're going to get a whole number here. So 2.84 divided by 0.405. The number I get is 7.01, which is approximately 7. What does this number represent? Well, this number means the number of water molecules you have. So our formula is MgSO4. To talk about a hydrate, here's what you do. You do a dot here, and you put how many waters we have. 7H2O. If we're going to name this, this is called magnesium sulfate. And then what's our prefix for 7? As we go back here, we find our prefix for 7 is hepta. Hopefully you already have that one memorized. Hepta, and then put the word hydrate. So this is our formula, what it asks for, and this, great circling job there. This is my name. So magnesium.7H2O, or I'm sorry, magnesium sulfate with a .7H2O. You're going to put magnesium sulfate heptahydrates. All right, let's look at another one. Look at this. For this one, they don't give us percentages, they give us grams, and they tell us they have 11.75 grams of hydrated cobalt chloride. It's heated. When it's heated, 9.25 grams of anhydrous cobalt chloride remains. What is the formula and the name of the hydrate? All right. Now, this word anhydrous, once again, means that there's no water present. It's all gone. So the first thing we're going to do if we get a problem like this is that we know the grams of the compound when it's hydrated, and we know the grams of compound when it has no water. So what I want to do is find out, well, how much water came out of this. And what I can just do is just subtract my hydrate from my anhydrous. Okay? So we're going to get 11.75 divided by my 9.25. Push the wrong button. 11.75 minus 9.25. I don't probably need to do this in my calculator, but whatever. And you get 2.50 grams. This is the H2O. This is your mass of H2O. How much you want to weigh? Because it did have water in it. We heated it, and now it doesn't. Subtract these two, and you can figure out how much water was in it. And from there, we're going to follow our steps. I've got 9.25 grams of my cobalt 2 chloride, which is COCl2. Okay? And I've got 2.50 grams of my H2O. Well, I got to convert grams to moles for both of these. My moles 1. Let's go and find cobalt. Cobalt's right here at 58.9. So I got cobalt, 58.9 grams. Chlorine's 35.5. And I have 2 chlorines. So when I multiply 35.5 times 2, I get 71.0. And I'm going to add this number and this number together, okay? So make sure you're adding these two. So 58.9 plus 71.0, when I add these, is going to give me 129.9. And that's my molar mass of my cobalt chloride. For water, it's 1 mole. I'm going to do this again, but hopefully we'll start to remember this. Hydrogen is 1, and there's 2 of them. Sorry, 1.0. So this is 2.0. Oxygen is 16.0, and there's 1 of them. Add them up, we get 18.0. And that is our mass of our water. So plug this in, 9.25 divided by 129.9. I get 0.0712 moles. Do the same thing for my water. 2.50 divided by 18, and I get 0.139 moles. Alright, so grams convert to moles. Last step, take your moles of water, 0.139, divided by your moles of your compound, and we should get approximately, if you've never seen this wavy line before, that means approximate. 0.139 divided by 0.0712, and I get 1.95222, which is approximately 2. So my formula is COCl2, cobalt 2 chloride, dot 2 H2O. The name of this is cobalt 2 chloride. Di is the prefix for 2, di hydrate. Alright, so we got our formula and our name, and that's how you do hydrates. This is important to learn because later on, and we'll hit this when we get there, later on, if I just want like 10 grams of copper 2 chloride, if I put this copper 2 chloride on the balance and get 10 grams of it, well, if you remember, it's not just copper 2 chloride, it's H2O is in there as well that's adding to the mass. Okay? So you're going to have to figure out, going kind of backwards on figuring out, well, how much copper 2 chloride or how much of this dihydrate do I have to add total? Because we don't want the water in there, we just want the copper 2 chloride. Okay? So we'll talk about that when we get there, just something to give you a heads up on. But for right now, be able to do these.